in the blanks to the first, or sorry, we're not here yet, not the theorem. So just like in side angle side, where the angle had to be the included angle, in angle side angle, you need to have the included side. So if these are my two angles that are given to me, the included side is the side that is common between the two angles. So if you think about your sides of the left angle, in highlighter mode, so there's the left angle, and if I think about the side of the right angle, which is over here, the overlap is the included side. Okay, so what angle side angle tells us is that if two angles and an included side of one triangle are congruent to two angles and an included side of a second triangle, then the triangles are congruent. So, in our description here, if I put my congruent angles down here at the lower left, and my second one, up here at the upper left, those are my two sets of congruent angles. The included side will be that left side. So that would be an angle side angle. Okay, so let's see if we can see the angle side angle on the next two examples. So for the first one, do you have two congruent angles? Yep, B and M and C and L are my congruent pairs. Do I have a congruent side? Right here in the middle. So if it helps, label angle, side, angle. Angle, side, angle. Is the side the included side? Yes. So are they congruent due to angle, side, angle? Yes. Triangle ABC is congruent to triangle N, B matches M, and then L. Okay. So on the next one, do you have a set of congruent angles? Yes. M and A are shown congruent. So there's an angle and an angle. You have MT congruent to AT. So now you have another side congruent to another side. Do you have another set of congruent angles?
Yes.
Yes. Where? The vertical angles are also congruent. Okay, so maybe on your blue sheet of paper, I would put a little star somewhere and say that you can assume sides congruent by reflexive property. Which in this case is not reflexive property. A lot of you guys on the quiz were just kind of adding in tick marks wherever you wanted to add in tick marks. You're like, oh, if I put a tick mark here and a tick mark here, then I have side, side, side. You can't add into the diagram. The only thing you can assume is congruent are sides by the reflexive property. And you can assume vertical angles are congruent. Because they are. So if they do have vertical angles in the diagram and they're not marked as congruent, you can make those congruent to each other. But you can't just all of a sudden decide, oh, I'm going to say D and N are congruent to each other. You can't do that. All right, so we do have a case of angle, side, angle, angle, side, angle. So yes, I'm going to go triangle MTN is congruent to triangle M matches up with A, T, D. Okay, so angle, side, angle. Two angles, one side. The side needs to be the one that is in between. So when we're doing our proofs for angle, side, angle, you need to have two congruent angles, one congruent side. Now the difference between the two is here we need it to have an included angle. For angle, side, angle, or sorry, angle, angle, side, it does not. So fill in the blanks here. If two angles and the non-included side of one triangle are congruent to two angles and the non-included side of a second triangle, then the triangles are congruent. So if we use those same angles as before, so congruent angle, congruent angle, congruent angle, congruent angle, and then maybe my non-included side is off to the right. Or maybe my non-included side would be on to the bottom. As long as it's not the side that is included between, then it's going to be angle, angle, side. Okay, so let's look at these diagrams and see what we've got. Huh?
Angle, angle side?
Angle, angle, side.
Wouldn't it be angle, angle side if it... It's hard to explain.
Huh? Would it be what?
Angle, angle...
Side.
Oh, I see.
Okay?
Yeah.
Alright, so looking at this diagram, I see that this C is congruent with that B, so there's one set of angles. Do I have vertical angles anywhere? No. Do I have the reflexive property somewhere? Yes. So that's in the middle, so that gets me a set of sides. Where's the second set of congruent angles? The right angles. Right angles are congruent. So the side is not between the two angles, because in between the two angles would be here at AB and here at DC. So it is angle, angle, side. So yes, triangle ABC is congruent to triangle DCB by angle, angle, side. Let's look at the next one. I don't have vertical angles. Do I have the reflexive property? Yep. N and M is congruent to itself. There's one set of congruent angles with L and O. N and M are congruent, and then you have your side. So yes, triangle LMN is congruent to triangle O. It would be M. Yeah. So angle, angle, side, angle, side, angle. Make sure you've got the difference between them.
This is angle, angle side?
Correct.
Okay. I'm thinking I'm gonna have a heart attack.
You're too young for that.
What was the other one for this one?
Angle side.
What do you mean? This side? Well, because you're two. Here's a triangle. Here's a triangle. But angle, angle, side. For this one, angle, angle, side.
What was the other part of this one? This is congruent.
So A would match up with D. So D, C, B. All right, so here we go. Proof number 1. Get your T-chart set up. Start filling in your given. So statements on the left. Reasons on the right. So angle S is congruent to angle Q. RP bisects angle SRQ. I try to give you guys the easiest proofs I can possibly give you.
No, I know, but I think you perfectly fabulous proof, so we can just it's not you, it's just the proofs. I'm not good at them, so it's
Unfortunately, that's what geometry is all about. All right, so first thing I would do is mark up the diagram with the given. Angle S is congruent to angle Q. Well, they already put the congruent symbols in there for us. That was nice. Do I have vertical angles?
No.
Do I have a reflexive property?
Yes.
Yes. What would my reflexive property be?
PR and RP.
Okay, now look here. Is it RP and RP will be the same, right? Again, I won't dock off points if you flip it, but in this case it doesn't get flipped. So let's get that in there for line 2. So RP is congruent to RP. Reflexive property.
Why doesn't it get for this one?
Because they're just kind of reflections of each other. So PR would not rotate to get to the other part. And if you look at the congruence, like the line above it and the prove line, they're the same. Okay, so I have an angle congruent to an angle. I have a side congruent to a side. So that means I either need to get another angle so that I can have one of these two, or I need to get another side in order to have side angle side. Okay, but that's not going to happen. Let's look up here. I see the word bisects. So then I would go to my blue reasons for proof sheet. And I would find an if-then statement that talked about bisects. Why did you pick angle, Roz? Because you were right.
because
It's bisecting an angle, right? So that's why we're going to pick the one that says if an angle bisector. Renee?
Shouldn't it be RP as congruent to PR?
No. Because those only are the case when it's like a parallelogram and they're rotations of each other. So when they're in a parallelogram, then it's a rotation. Here it's just a reflection over. So it's the same. Plus, if you look here, RP and RP are in the same spot. But will I take off points if you flip it? No. As long as you get the right letters and the reflexive property, I'll be fine with that. Okay, so we've got RP bisecting this angle. What happens when it bisects an angle? It gives us two congruent angles. So what are those angles? Well, this one is angle SRP. So my line 3 is going to be angle SRP is congruent to. On the other side, it would be what? QRP, good. And then what was that if-then statement? Angle is bisected, then two congruent angles. You should have something like that on your blue sheet of paper, even if it's as simple as if angle bisected, then two congruent angles, or if angle bisector, then two congruent angles. All right, so now do you have three things? I see an angle, that's one. I see a side, that's two. I see an angle, that's three. So now it's debating on whether these are congruent due to angle side angle or angle angle side. Which one do you think it is? Yeah, why do we think it's angle angle side? Right. For it to be angle side angle, it would have had to be SR and RQ. All right, so rewrite your prove line. Triangle SRP is congruent to triangle QRP due to angle angle side congruence. Okay. Huh?
That was a long one.
I've only been talking for 14 minutes. All right, last one. Set up your T-chart. Statements on the left. Reasons on the right.
Are you recorded?
Yes.
So we're going to go on your YouTube?
Huh?
Are we going on your YouTube?
Yeah. Line 1 XQ is parallel to TR. XR bisects QT. Given. All right. Am I given any congruencies right away in my given statements? Nope, I don't see anything being congruent to anything. So that means I've got to get all of it that I possibly can. So then I would look for, do I have a reflexive property anyplace? Nope. Do I have vertical angles anyplace? Yes. Where are they? At M. Now we have to be particular about it because there's 1, 2, 3, 4 angles at M. So I'm going to use 3 letters to name it. Oops, that's line 2. So I'm going to say angle XMQ is congruent to, Sam, if I go XMQ, what's the other part going to be? Sam, RMT.
Yeah.
Do you see that? What's my if-then statement going to say?
Oh, you're still talking?
Well, what are we, if vertical? Yeah, you're almost there. If vertical angles, then congruent. Okay. I see parallel. 99.9% of the time, the proofs I'm going to give you, parallel lines get us what? Alternate interior angles. Okay, so now I've got to figure out where my alternate interior angles are.
Yeah.
We just did M. Those are vertical angles. What would be congruent to Q? T. Are those alternate interior angles? Yeah. Okay, because they're rotating on the opposite side of this transversal. Okay, so let's do that. Line 3. Angle Q is congruent to angle T. If parallel, alt, int, angles congruent. Good. Okay. We could have also gone with X and R. Those also would be congruent to each other. But there is no angle, 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 so we can't go with that. And if we did do that, then my final statement will be a little bit different. All right, so now I've got one congruent part. I've got a second congruent part. 2 angles means I'm either going with this or this. So that means I need a side. Where's the side going to come from? Bisects. Are we bisecting an angle or a segment? We're bisegment a segment. So that means QT is being split in half. So what are your 2 equal parts if QT is split in half? Good. QM and MT. So line 4. QM is congruent to TM if seg bisected, then 2 congruent segs. Now do you have 3 congruent parts? Yep. 1, 2, 3 congruent corresponding parts. So my line 5 is my prove line. So triangle XMQ is congruent to triangle RMT because of what? Try again. Try again. Angle, side, angle. Good, then. So we've got 2 angles, 1 side. And it's just a matter of deciding where that side falls. All right, I need you to grab yourself a Chromebook and take it back to your seat, please.